The study area is just north of City Hall here. It's within the Highland Creek watershed. And what we wandered through when we started the process, we looked at what was the critical and driving forces, and we started looking at individual stream reaches, and they're highlighted in yellow there. The wish list was first off to build on what we learned in Clayton. Second thing was reduce cost. And that was driven primarily by the developers who had a lot of small parcels, and there wasn't a single large developer that had a big stake. So they were all a bunch of little 10, 15 lot, the problem developers. And the question that was asked was, can we reduce or eliminate the detention ponds? So that was really the driving force. Here again, we were proposing the on-lot systems, and when we do that, we were looking only at about 60% of the neighborhood, because 30% or 40% are in the streets. We had a couple of in-street systems that we proposed, and I'll admit we borrowed these from other places that demonstrated these systems work. The first one is the infiltration system is around the storm pipe in the road, with a second perforated pipe to carry the flow through. The manholes were deepened to provide a sump and to protect the systems. We also put a sump and an oil grit separator in the catch basins as part of the design. And all through construction, we were blocking off the infiltration galleries themselves, so we could actually survive the construction period. As an alternative, we went with a system behind the curves, an infiltration system that fed off the catch basins, very much like the system that James were proposing. The only difference was we only teed off and put a tee from the catch basin into the gallery rather than a continuous perforated pipe along the length of the gallery. We felt that was would encourage more storage, more infiltration, and less flow through the pipe itself. We went through, here's my charts again, and some people don't like them, but what we went through, we looked at a whole series of systems, and what we found was sizing the systems. What was critical was the surface area, how much of the watershed was going to be underlain by these infiltration systems. And we were testing in our analysis a number of different sizing, anything from nothing to from 2, 3, 4, 5% of the catchment area. And what we ended up with, we said that what would work best is a system that would underlay 5% of the catchment area. So it would have to be on the lots and in the roads, because we couldn't get 5% of the catchment area under the roads, because the road alignments were already fully utilized. You can't squeeze the extra area of the infiltration system into the roads. It's just physically not possible. The second thing we looked at, and this is the building or the leaving off the bridge from East Clayton, we looked at the erosion potential in the stream and in those reaches. This is a typical example of the analysis results, and this is a comparison on Reach 5, which we looked at the erosion potential under pre-development, which is on the left, post-development, which is the next one over, because there was so much drainage with the ditching and things already. There wasn't a lot that full development wouldn't significantly increase the erosion. But when we started introducing the actual infiltration galleries, shaving off some of the smaller flows and the intermediate flows, and using those systems actually as storage as well as infiltration, we started seeing a real benefit in the erosion reduction. so much so that when we look at on the right 2%, 3%, next one over, 5%, the 5% area, the BMPs provided a significant erosion reduction. That was a major thing. So and this was without any kind of a detention pond. The next thing we looked at was flood risks and conveyance capacities. When we looked at when we did the modeling, we looked at how much would the development increase the discharges. And in every case, with the infiltration systems in place, there was a slight increase in the flood flows. We then looked at each reach individually and said, what impact would that have on each reach? And there was only one reach where we would increase, where the flooding would be a factor. And it was already a factor before development or redevelopment. So in every other case, the existing streams would be capable of carrying the post-development flows. Now keep in mind, this was with the infiltration systems providing a distributed storage function. And the flood-prone reach, or flood-prone reach was, this is a couple of pictures from that. You can see the ditch that had been cut through the lot. And on the right is the actual inlet to the culvert under 142nd Street. So it was a problem now and it needs to be fixed. So development wasn't going to change that, but we just identified that it was an issue. So what did we find at the end of the day? Well, we found that we could actually eliminate the ponds. And there was a potential DCC fund savings of some $6 million from this neighborhood. Putting in the erosion, or the infiltration systems and using them as distributed storage provided an erosion reduction in the stream, which was one of the primary goals of what we were trying to do. If we do that, we found we didn't really alter the flood discharges all that much. And we didn't really change the flooding all that much. So, what did we recommend? We recommended that we build the systems on lot in the streets. We eliminate construction of the ponds. The city has required that the areas for the ponds be acquired and ultimately built if required. But right now, the properties are sitting without ponds, and so that's what we're doing. The problem, though, was in the execution. How do we get them built? And especially with the small developers. And I think we have time to have Sam stand up and talk.